As far as we can tell, Galileo was the first person to point a telescope at the sky. He wasn't the man who invented the telescope. It was invented by someone named Hans Lippershey. But Galileo heard about the discovery, and he made himself a telescope, and he pointed it at the sky and made monumental discoveries. And then he used these discoveries to disprove, one by one, all the principles of the Greek geocentric model. And that's what I'd like to focus on now. This happened in the year 1609, and so 400 years later. When I say this happened, I mean his first telescopic observations. And this was celebrated throughout the world in the year 2009 as the International Year of Astronomy. I'd like to focus on 4 objects that Galileo spent a lot of time observing. Let's start with the moon. If you get your hands on a small telescope, the moon is probably one of the first things you'd want to look at. It's nearby, it's big, it's pretty. And Galileo looks at the moon and he comes to some pretty remarkable conclusions. He sees clearly that it has ups and downs. Remember that in the Greek geocentric model, there was a belief that all the celestial objects, all the heavenly objects, had to be perfectly round, perfectly spherical. They couldn't have any ups and downs. Galileo looks at the moon and he says this. He says, consequently, anyone may know with palpable certainty that the surface of the moon really is not smooth and polished, but instead rough, uneven, and just like the face of the earth itself, everywhere full of vast protuberances, deep chasms, and sinuosities. Now keep in mind, most people don't believe this, but he's being a really persuasive writer. He's saying everyone will know as soon as they look through my amazing telescope that the moon is just like the earth, it's got ups and downs. And immediately he backs it up. He says, indeed on earth about sunrise we have a very similar phenomenon. We behold the valleys not yet flooded with light, while the mountains surrounding them on the side opposite to the sun are already ablaze with the splendor of his beams. Now let's look at this image of the moon. Obviously this was taken much more recently. Here's a close-up of one area of the moon. Now if you look at the light and the shadow here, you can probably figure out which direction the sunlight is coming from. So if you look here and you look at the craters, you can probably figure out where the sun is. Okay? You probably figured that the sun must be back here. The sunlight's coming from over here and hitting the bottom of the craters. So this side of the crater is lit up. The bottom of the crater is lit up. The entire bottom portion of the crater, everything except for the top over here is lit up. And the bottom of the crater here is lit up. Every crater, in fact, is lit up at the bottom, but not necessarily at the top. The shadows that we're seeing are from the crater walls, the crater rim. And it's the top of the crater casting a shadow onto the bottom of the crater. And we see them at the tops of the craters, not the bottoms. So we can tell where the sunlight's coming from. And so what Galileo is saying, if you look through my telescope, you can see light and shadow for the first time on the moon. You can see this with the naked eye. And he says, look, the moon's not that complicated. It's just like what we see at the earth. If you wake up early in the morning and you go out, if you happen to be by a valley or the Grand Canyon or any place like this, you see that if the sun is behind you, it hits the mountains on the opposite side before the sunlight gets down into the valley. It's a simple concept that people can grasp, and so he's taking this distant object, the moon, and bringing it a lot closer to home. So Galileo's telescopic observations of the moon showed that, just like the Earth, it has ups and downs. It's got, in this case, craters. It's got indentations. And he figured this out by looking at the light and the shadows on the moon. Another object Galileo looked at was Jupiter. Jupiter is a planet. The word planet means wanderer. So planets, unlike stars, but like the sun and the moon, wander from constellation to constellation. The stars in a constellation will always be in that constellation. They'll never leave and enter a different constellation. But planets go from constellation to constellation. They go through all the constellations on the ecliptic, the zodiac constellations. So on January 7th, 1610, Galileo points his telescope at Jupiter, and he sees two stars, within quotes, close to Jupiter on one side and one on the other side. So he sees two stars to the east of Jupiter and one star to the west of Jupiter. He could see a lot more stars through his telescope than he could with the naked eye, so with one observation it might not be terribly surprising that there would be some stars right by Jupiter that he couldn't have seen with the naked eye. And then on the next day he sees three stars. All of them are west of Jupiter. So if these really are distant stars and Jupiter is just drifting along from one constellation to the next, I guess you would assume that Jupiter moved to the east. Since Jupiter moved to the east, all three stars now appear to the west of Jupiter. Galileo went out again the next night, but unfortunately it was cloudy. But on the following day, January 10th, 1610, this is what Galileo saw. He only saw two stars. Again, you probably guessed that these really aren't stars at all. He only saw two of them. Now both of them are on the east side again. And he figured the third one must be hidden. Now, if these really are fixed stars in the sky, and at one point Jupiter was in between three of them, meaning it had two on one side and one on the other side, and then the next night he could still see all three, it really doesn't make sense for Jupiter to move backwards and now block one of the stars with two of them still visible. What is much more likely is that these really aren't stars at all, they're moons. On the previous slide, here's a diagram showing observations made on many different nights, and in fact there were 4 moons that Galileo discovered. They're now named after him, the Galilean moons, and he could show night after night after night that these aren't fixed stars in the sky, these are little moons, they orbit Jupiter. The significance of this discovery is that it casts doubt on the idea that everything goes around the Earth. Well, here are 4 things that go around Jupiter. So why should we assume that there aren't other things that go around Jupiter? So one by one he's dismantling the geocentric model of Ptolemy. He's saying, why is it unreasonable to think that we go around the sun? Here are 4 moons that go around Jupiter. Perhaps not everything goes around the Earth. Another object he looked at was the Milky Way. Here's a recent image of the Milky Way that I found on the Astronomy Picture of the Day website. With the naked eye, you just see this fuzzy patch of light that looks a bit dusty going across the sky. Again, you have to go to a very dark, remote location on a clear night to see it. And with the telescope, you can see a lot more. This is a longer quote, but it's a good one, so let's read it. Galileo says, "The next thing I observed is the essence or substance of the Milky Way. With the telescope, this can be perceived so palpably that all the disputes that have tormented philosophers for so many centuries are quashed by sheer ocular proof, and we are released from all those wordy arguments. For the galaxy is nothing else but a mass of innumerable stars, planted together in clusters. Point your telescope in any direction within the galaxy, and at once a great mass of stars comes into view. Of these, many are fairly large, meaning bright, and robustly conspicuous, but the number of small ones, meaning faint ones, is utterly unfathomable." Basically what he's saying is this: with the naked eye, you only see a couple thousand stars. But with my telescope, you can see many more stars. Why couldn't you see them with the naked eye? Because they're faint. Why are they faint? Probably because they're really far away. What does this mean? It means there's a lot more stuff out there in the universe than you previously thought. The universe is much larger than we had previously imagined. There are a lot more stars. It's a much larger universe. And so our place in the universe is much less significant than we had believed. If we had thought there's only the sun, the moon, and 5 planets, and maybe 2,000 stars, it's one thing to think we live in the center of all of that. But now if you see thousands and thousands of stars out there, tens of thousands of stars, maybe millions of stars, then it's something else to still have the arrogance to assume that we live at the center of all of that. In my opinion, the most significant observation of Galileo's in terms of disproving the geocentric model of Ptolemy was that Venus, just like the moon, goes through phases. By now I think you all understand the phases of the moon. Let's now apply this to Venus. A few words about Venus. Venus is usually the brightest planet in the sky. Not always. Sometimes Jupiter can appear brighter. Venus is referred to sometimes as the morning star. Sometimes it's called the evening star. It's not a star at all. It's a planet. But it is true that it's only visible in the mornings and the evenings. The reason for that is that it's close to the sun. So people throughout history have known that Venus is not observable in the middle of the night. It's never high in the sky at midnight. You only see it close to the sun, which means you only see it just after sunset or just before sunrise. But with the naked eye, you don't see the phases. It looks like a bright dot. You can't see a little crescent or a half Venus or a gibbous Venus. It just looks like a really bright dot. Let's now look at Ptolemy's view of the motion of Venus and Copernicus's view of the motion of Venus. Galileo, of course, agreed with Copernicus. In both models, Venus always stays close to the sun because that's what we observe. We always see Venus close to the sun. So in Ptolemy's model, as the sun moves, Venus moves with it, but it always stays in front of the sun. And if it's always in front of the sun, then it should always be new or crescent, but it can never be more than half full. You can never see a quarter Venus, and you definitely cannot see a full Venus or a gibbous Venus. If that's unclear to you, please go back and review phases of the moon. By now, I think you should really understand what causes phases. Now, before the invention of the telescope, this wasn't an issue. No one could see the phases of Venus. If you asked someone that knew about Ptolemy's models what Venus's phase should be at any given time, they might be able to draw it out and tell you, yeah, right now it should be pretty close to a new Venus, or right now it should be pretty close to a crescent Venus. Of course, if it's a new Venus, you can't really see it, but if it's a crescent Venus or if it's a gibbous Venus, it can never be a gibbous Venus. It's either new or crescent. They might be able to tell you right now it should be a crescent Venus, for instance, as opposed to a new Venus. But with the invention of the telescope, you could actually see the phases, and you can see that sometimes Venus is full. There is no way to explain a full Venus in Ptolemy's model. According to Ptolemy, Venus should never be full. It should always be close to new. And so, in my opinion, this was the last nail in the coffin of the geocentric model. There is just absolutely no way you can reconcile Ptolemy's model of the solar system with two things simultaneously. Those two things are the observed phases of Venus and the fact that Venus always stays close to the sun. As the sun moves, Venus moves with it. You never see Venus on the opposite side as the sun. You never see the sun on one side and Venus on the opposite side. It's always in the same side of the sky as the sun. So for it to be on the same side, the only way it could ever be full is if it's on the opposite side. Meaning, by opposite side, I mean it's on the other side of the sun. It's on the same side of the sky, but it's beyond the sun. And so the sunlight shines on the same side of Venus that we can see. All of these discoveries got Galileo into all kinds of trouble. If he had been more modest in presenting them to the public and to the church, maybe he wouldn't have got into trouble. He was perhaps a little too abrasive about it and a little too aggressive, and the church wasn't having any of that. Galileo was put under house arrest, and he was asked to destroy all of his writings and his telescope and to basically recant, to say that the Earth really is at the center of the universe as opposed to just being one planet that orbits the sun. Pope John Paul decided this had gone on long enough, and by 1992, long before then, everyone knew that the Earth goes around the sun, and this Pope wanted to really have the church embrace science more so than before, and he thought, better late than never, let's issue a formal vindication of Galileo. And so the present-day Vatican does not view Galileo's contributions as contradictory to the teachings of the church.